Hello. I have been working on a game kind of in Java, but it's also works as a 3D renderer. I originally started this project using a different tutorial that I can link. It's very old, but it did the trick. But I kind of deviated from that and I started making a kind of dungeon game. So first I can show you what it looks like at the moment, then I'll go over some of the code. So it pretty much just generates all these different pillars randomly. If I press this button, it'll generate new rooms with enemies and spikes on the floor. I don't really do anything yet, but they're there. I'm gonna try to find one with spikes. Yeah, here's a spike. But anyway, close out of that. Um, I guess let me start with some code. So this is my screen. There's just a lot of stuff in here. These are like the controls kind of. Um, this generates a room with the size. This is like the collision system. So pretty much everything that needs to have a collider, which right now is just the pillars, it has its own set radius, and then the player also has a radius, and it pretty much just checks if the player is near the object's collider radius, and then it'll just stop you from moving. More controls. The set order. I've been working on this a while, so I can't remember exactly where this is implemented, but you pretty much need to check in what order the different faces are. So each face is a polygon, and I think for rendering purposes, I needed to figure out which face was in front of what other faces to decide what gets rendered in front. I think that's what that is. Paint component just pretty much fills in all of the polygons and all of the different shapes. This sleep thread is just to continually paint all of the different polygons. I think I have it every frame at 60 frames per second. I'll just get some resources here. These are like the only textures I use. I'm trying to keep the game as small as possible, but this is just a bunch of whatever. The actual important stuff comes in. So here's polygon object class, which you can learn more about in the video I'll link, because that's where I got this from. I just slightly changed it to fit my own purposes. So pretty much you can store different polygons, and I have a constructor where it can take a buffered image. So that's like my cobblestone tile, or it can also just take a color, which the pillars are just gray. So whatever I need for my purpose is what it uses. The polygons update every frame, and then this draws the polygon on the screen. I'm using a different library than what would be usual, just because of the fact that I need to draw the textures rather than just a solid color. I'm using this graphics 2D class. And another thing to mention is that my renderer isn't true 3D because I'm not using a Z buffer, which, if you know anything about graphics programming, that's kind of like a big thing for 3D. But the math gets very complicated, and I just decided to keep it simplistic. So you play the game, and it looks like it's in 3D, but it's actually what you would call, I think, a painter's algorithm. It's like 2D pretending to be 3D, and the shapes are kind of just drawn over the screen and stretched and changed to look like it's in three-dimensional. And then this three-dimensional polygon class uses the individual polygons to make 3D shapes. Just the constructor is pretty much the same as a normal polygon, except it has arrays of different X, Y, Z, then it takes the image, or it can take a color. So this is where you get the differentiation between a shape that will have just a solid color or an image texture. This also gets updated every frame. This method gets called, but another thing that's added is it checks if it's visible to the player, because if it's not visible, if it's like behind another face or the player isn't looking at it, it will actually cull the face and it just won't render at all. Because otherwise, I wonder if I can demonstrate this here. Alright, I couldn't break my own code to show you what I was trying to describe, but just believe that it's important to disable faces that are not in the view, especially ones that end up going behind the player. So the next class we'll look at is my room class. So this is actually what generates a room. Let's see what we got here. So we got the width and the depth of the room. This is just an array of colliders. I don't have best practices in a lot of my code, just, I don't know, it's just the way I do it. So I just set the max array length to 200, just as a big number that it doesn't store too much, but it's also enough. This is just the number of colliders that are currently in scene. I have this 2D array that actually keeps track of which kind of tiles in the room are occupied, so it won't generate anything like on top of each other. So like a pillar won't generate on a pillar, an enemy won't generate on a pillar, and a spike won't generate on an enemy or pillar. So this is just like a room constructor. You just take the width and the depth, and then I occupy the space 2, 2 because that's where the player spawns, and you don't want the player to get stuck in anything. And then I just call all of these to generate. So to generate the floor, I just have some for loops that generate squares as tiles on the floor, and they're actually 2 units wide on the X and Z axis, and then they use the tile image. For the pillars, actually had 2 different approaches to this. The first was much worse. You can see my commented code here. I manually figured out how to make all of these different faces to make a pillar, and I thought, well, this looks horrible, so how about I just do it in a for loop with adjustable parameters. So I think that's actually down here. You can adjust how many sides you want to have, where in the tile it will spawn, and then this is just some math to actually generate the pillar. Then it makes sure to add a collider to it, and it also takes up space in the collider array when you see occupied, and then it also occupies the tiles next to it so that you can't spawn like a wall of pillars that the player wouldn't be able to walk through. Alright, to generate enemies, it's pretty much the same exact thing, except instead of generating a pillar, it just generates one polygon face, and it just fills the face with the skeleton image, and it's a PNG with transparency. So just from the library that I used, it won't take up the extra space on the polygon, it won't fill in the color, it's just transparent. and then generate spikes. Once again, same approach, but it's like a pyramid kind of shape, and it's just the color black. This is just a class that I made to play music. I'm sure you heard it when I ran it. I can run it again at the end of this. I just made a quick little song in FL Studio. Just, I don't know. It's nice to have music in a game. Now this calculator is probably the most complex part of the whole thing. It is basically just calculating how all of the faces should be and how they are shown to make the scene look 3D. And you can tell it's my better calculator class because I had a different calculator before that came from the tutorial I've referenced, but it just wasn't working for what I needed, so I just rewrote the whole thing myself. The math is pretty complicated. I'm not going to try to explain it all here, but if you have any questions or anything, you can leave a comment and I can either respond or I can make another video explaining more. Once I finish this project, I'm going to release the source code, probably on like a GitHub, for anybody to look at if they want to learn more about rendering in Java. This is my camera class. It's pretty simple. It just keeps track of the position and the rotation. One of these actually doesn't get used. The camera can only turn left and right. I think that's the pitch that's up and down. I kind of forget, but somebody smarter than me would know. And I knew at one point. I just haven't worked on this in a bit, and I'm coming back to it. This is the collider class. It just keeps track of the size of the collider and, well, the size of the object and collider. Projection. It just keeps track of parameters that are used in the calculator. As you can see, it's actually creating a projection here in the calculator so that the shape is projected onto the scene. The vector. This is another heavy math class that is also just for drawing the polygons in the 3D space. And then I have my main class that I did not utilize how I should have, because my screen class pretty much turned into main, but not everything's perfect when you're coding. Can run it one more time, just to give all the overview. Got colliders on the edge, colliders on the pillars, no colliders on the spikes, but eventually it'll just damage the player, which I'm going to start working on right after this. It seems like this specific dungeon did not generate any enemies, but we can regenerate. There's one. Everything has an outline. It's just the way I set up the code. That could change, but it's just easier to keep it the way I have it already, and I don't mind it. But that's pretty much all of it. So feel free to ask any questions. I'm sure there's a lot I can expand on. I didn't do a great job at explaining, but it's just what I'm working on right now. Once I actually finish it, I'll be sure to link the GitHub or wherever I decide to put the source code and the actual game itself. So I guess just look out for more.